Okay, thank you very much for inviting me to this great event. And yes, I'm Takehiro Nakamura from NTT DoCoMo Japan. And in this presentation, I'd like to explain the DoCoMo's concept and activities for the 6E technologies and the use cases. And values of 6E, yeah, many people already mentioned that this should be aligned with others, maybe, but the AI everywhere. So AI for network is a baseline for the 6E. On top of that, we identified 5 values like this: sustainability, efficiency, customer experience, network for AI, and connectivity everywhere. I'd like to explain one by one. By the way, can I talk for 20 minutes? Okay. Okay, so sustainability, yes, of course, this is very important. And yes, many of the companies has already declared the target of the sustainability. And even for us, NTT DoCoMo and the NTT Group declared that the carbon neutrality by 2030 for scope 1 and 2, and net zero emissions, including the scope 3 by 2040. And the key focus area should be, of course, AI can be useful for the sustainability and in terms of the power saving. And also our group is aggressively working on the advancement of the optical technologies, so-called ION, photonic electric convergence. ION, yes, this is originally proposed by our parent company, NTT, innovative optical and wireless network concept toward the 6G era. And we set a very challenging target, yes, in power efficiency 100 times greater, transmission capacity 125 times larger, end-to-end delay reduced to 1/200. And especially for the sustainability, of course, the power efficiency is very important, and this can be drastically improved by the photonics electronics convergence, PC, PEC. And we are already developing the PEC devices and with the phased approach. And finally, our PEC devices, optical technologies can be used even for not only for the transmission, but for the computing can be done by the optical, so that we can reduce the power consumption drastically. Efficiency, yes, and as Deutschrock mentioned, that the 5G was so complicated, and many people has a strong requirement and hope to have a streamlined 6E specification, simplified 6E specifications. And of course, for the 6E, the simplified design would be definitely needed in the 6E, and AI-driven automation and optimization. And also, in order to improve the radio efficiency, we need to include the new technologies in the 6E radio, the large-scale MIMO, AI-native RAN, control signaling reduction, and so on. Yeah, we can have a variety of the technical elements to improve the radio. And also technologies for the utilization of the higher frequency band. Yes, I know that yesterday we had some discussion on the millimeter wave and the sub-terahertz, but especially my feeling is European people don't like millimeter wave or sub-terahertz. I don't know. But I am the fan of millimeter wave. I'm a supporter of the millimeter wave. I'm shouting the millimeter wave all over the world. And yeah, actually, we have nice technologies to improve the millimeter wave coverage easily. Yeah, especially maybe even in the many academias, they are researching the metasurface materials, like a metasurface lens window, and also RIS is a very interesting devices. And also many people addressing the network digital twin to optimize our network in the cyberspace, yes, and easily. Especially network digital twin for the 6E is very important, of course. And physical world network data, many of the data should be transferred to the cyberspace and compute, calculate the performance, and then immediately the result of the processing should be reflected in the physical space. So this kind of the circulation should be done very, very quickly, almost real-time manner in the 6C era. That should be very good. And as initial step, and in order to do the simulation of the real world, we developed the digital twin simulator using the point cloud data. Currently, point cloud data can be get very easily using the existing many of the devices, like the left-hand side picture. And point cloud data is converted to the polygon data, 3D polygon data, and then that can be used for the simulation, ray tracing simulations. Actually, we are collaborating the company Omron, and we get a point cloud data of the Omron factory, like left-hand side factory. Yes, this is the real world. And point cloud data is used, converted to the polygon data and inputted to our simulation. And the simulation results showed in the right-hand side. And as you can see that the real environment, based on the real environment, we can simulate radio performance with the flexible manner. Yes, we can set base station antenna very flexibly. We can put the users very flexibly so that we can simulate the performance in the real factory, yes, using this kind of tool. Yes, this is good for us and also for our customers, partners, to know the potential performance to use the radio, 5G radio and the potentially 6G radio in the future. And also sub-terahertz. Sub-terahertz, priority of the sub-terahertz is now rather low. But considering the traffic increase, as Magnus mentioned, yes, traffic will be increased in the future due to the AI application spread. So on the other hand, the spectrum resources are very limited, especially a lower band, almost nothing. So mid-band also very difficult, but we should use a higher band. And but of course, sub-terahertz, we have many challenges to deploy in the real market. But yes, we should try to prepare the potential use of the sub-terahertz for the future. Not the day one of the 6C, but maybe second phase, third phase of the 6C. Maybe there is a possibility to use the sub-terahertz, I think. So in that sense, some research for the sub-terahertz use in the commercial market should be continued. And I hope that the academia can continue the research for the sub-terahertz to be used in the 6C era. And customer experience need to be improved, and we should provide excellent services, applications, and also reliability is very important. We think that the mobile communications are lifeline, one of the lifeline already. So our network should be very resilient and robust. So we should, in the 6G network, we should realize such kind of the resilient, robust network. And also we should try to identify the new applications toward the 6G era. Now we are very aggressively working on the so-called field tech. Field tech is new technologies for the 5-sense communications. And the field tech, yes, so far most of our application services are based on the voice, image, and video. But our field tech concept can share the emotion and the sensations also, so that we can realize, for example, master craftsman's techniques, sharing the master craftsman's technique, and sharing the feelings across time, and sharing the skills of the professional athlete. This can be achievable in the 6G era using this field tech technologies. In order to conduct the trials and the demonstration, we developed the human augmentation platform. And the human augmentation platform has a capability that comparison and adjustment of the different human body data, expansion, reduction of the sensory motion range, diverse interconnectivity, device interconnectivity, and the device connectivity is simplified with SDK. And using this platform, we already showed some demos, such as the haptic sharing and the motion sharing using the myoelectricity, and also taste sharing. Now, taste can be dataized and transferred through the network and then reproduce the taste. Yes. So taste sharing is already possible. And we will continuously working on the field technology to create a new applications based on the human data, emotions, senses, movement, and the thinking. Yeah, brain technologies also can be used. And some combination of this kind of data can create a very, very brand new and interesting services for the future. And we established a consortium to develop the ecosystem of the field tech, human augmentation. And we are trying to proceed the demonstration and the experiments, and also to develop the ecosystem. International standardization need to be done through this kind of consortium. So if you have any interest in this consortium, please contact to me, or please contact to this email address. Yes. Okay. And next, network for AI. Yeah. Yes, for the variety of the AI application will be provided and created for the future. Yeah, of course. And our network need to be optimized for the AI applications, of course. And we can consider the many kind of things, not only the higher data rate capacity, the lower latency, and so on. And one of the example is in-network computing technologies. We are now aggressively working on this. And this is especially for the video-related services processed by AI. That will be increased more and more for the future. But on the other hand, in the market, there are many, many low-end terminals. And many of the low-end terminals cannot cannot do the process of the high-quality video with AI. In that case, the offloading of the processing from the terminal to network should be very good approach. This is in-network computing. And we developed the experimental demonstration system of the network computing used the camera API gateway. And through the camera API gateway, we triggered we can provide the triggers to start the in-network computing process. Yes, like this. Yeah, this is one of the approach. And in any case, as one of the example of the network for AI, we should consider this kind of things in our network, future network. And finally, I'd like to explain the connectivity everywhere. Yes, NTN is a very, very interesting topic for everybody now, I think. Yes, even for my company also. And actually, our approach is maybe similar to the Deutsche Telekom. Yeah, we will have the intention to use the several solutions, case-by-case basis. We have a solution such as the Zio, Leo, HAPS, and the terrestrial network. 4-layer, multi-layer usage as a NTN-TN integration should be developed and deployed in the future. Yeah, actually, we have already deployed Zio for many years, for several 10 years. And, but performance is low due to the very, very long distance. But Leo, that could be nice, yes, now. And many applications, many services already utilized. And also, we are also very interested in the HAPS solutions. Yes, I will explain next. HAPS. Yeah, as you know, the distance is very short compared with the satellite solutions, only around 20 kilometers. So we can achieve the very high data rate and the low latency compared with the other solutions, satellite solutions. So, but the coverage per one aircraft is limited compared with the satellite solutions. But if we need a higher performance in the limited areas, but not small, but rather wide area, maybe hubs should be used, yes, rather than the satellite solutions. So in any case, we can consider to use these kind of several solutions, case-by-case manner. That is our approach. And hubs, yes. Recently, we had a very good success on the hubs. And for years, we are collaborating with Airbus and subsidiary company, Alto company, to develop the hubs communication services. And we had a success in the hubs communication in Kenya in this January and February. And we achieved 4.46 megabps downlinks and also 13 days continuous flying, yes, using this aircraft. So yeah, that was very nice. And I can show you some videos here. This is hubs takeoff, yes. This is a hubs, that name is a Zephyr, yes, developed by Alto. Actually, Alto developed this aircraft in the Farnborough in UK, yeah. Yes, this is the scene of the takeoff. I'm sorry that that was nighttime, so it is very difficult to see, yeah. But please look at the right point of light. Yes. Where? Yeah, over there. Yes. And this is the takeoff scene. Yeah. Everybody happy? Yep. And next, this is a hubs flight in the stratosphere. Yes, the video quality is not so good, but this is a real one. And that aircraft flying in the stratosphere like this. Yes. And landing, yes, aircraft has come back after the 30 days, right? Yes. And touchdown, yes, like this. So anyway, like this, the hubs is now available, and but still we need to do the testing for the more stable stability of the aircraft and the stability of the communications. Okay, so hubs, that's it. And also, not only the communication, the hubs can be used for some other sensor from the sky. And the optical camera is, of course, a very useful sensor to be installed in the hubs, and also other sensors like detect CO2 level or locate mineral veins or something like that. Yes. So hubs can be used for the multiple use cases, not only the communication. That should be very nice in the future. Okay, that's my presentation. Thank you for your attention.